Hello friends, this is Hidayat Basha, Assistant Professor in R.M.K College of Engineering and Technology. Now I'm going to share the knowledge of radiation mechanism and design aspects in the subject antenna and microwave engineering. Now this is the syllabus for the final year students, where in the radiation mechanism and design aspects they have these topics, that is radiation mechanism of linear wire antenna and loop antennas, and then aperture antennas, reflector antennas, microstrip antennas, and frequency independent antennas, and their design considerations and applications. So this is about the syllabus of the second unit, right? Then now coming to the course outcome, specifically this unit is the second unit, so the course outcome is the CO C401.2 and C401.3. so two COs has been taken for this particular subject, for this particular unit. So for the second unit, the first outcome, the course outcome is, so we are going to compare the radiation mechanism of wire antennas and the loop antennas, and we go up to the cognitive level, that is the K3 level. Okay, and then next, coming to the second CO in this particular unit, design and assess the performance of aperture and frequency independent antennas. So this is another antennas we have, where aperture and frequency independent antennas. So we are going to design the performance and design the antennas, and we are going to observe the performance of these antennas, and even this we are going to take to the K3 highest cognitive level. Okay, now coming to this particular, according to the objectives, so how and when the radiation takes place in antennas. So if we see when the radiation occur, so if we have a conducting rod, and for that conducting rod if we give any DC source as the input source without any change in the current, right? So if that is if the conducting current is uniform velocity, right, then definitely there will be no radiations in the conducting wire or the conducting. So when the radiation occur means, so the conducting, so that is the radiation occurs in a conducting wire if the feed whatever we give, that is the voltage source whatever we give to this particular, give to the antenna or the wire, conducting wire, that input should be like an oscillating current. So if we can just give AC current to the wire, then it will produce some electromagnetic field out of it, right? Or if we give a steady current, then the material, that is the conducting wire, should be like a bent one or a discontinuous one, or it should be terminated or truncated one, right? Then next, now we have like dipole antennas and monopole antenna. So the wire antenna comes into two flavors actually, namely the dipole antenna and the monopole antenna. Dipole antenna is, we can see dipole antenna is a balanced wire antenna, whereas monopole antenna is unbalanced wire antenna. So where we can see for the dipole antenna, it has from the transmitter or receiver, there are two poles, right, and they are connected. That means we are going to connect, right? We have two dipoles, like positive and the negative, whereas in monopole we have only one and the other one is grounded. So in monopole, one end is grounded and another one is used for transmitting or receiving us, right? And this is about the electrical field and the magnetic field around the transmission line. This will be this is known by the Fleming's right hand rule, right? According to the current direction, we have the curl of the magnetic field around, right? So this is about it, and it is very important how the current is, that is how the field is, electrical field is propagating. Now here we can see here that the current is when the current is propagating, the field exhibit. Now the field will be from positive to negative, right? So it will be like a circular loop, and the magnetic field will be like 90 degrees to each other. So that is, the magnetic field and the electrical field will be orthogonal to each other, right? Next we just see how a transmission line is being converted to an antenna. If we can see, right, if we have only a transmission line, that transmission line will be insufficient to radiate the energy, right? So it will not radiate any electromagnetic energy. That means in a transmission line with only two wires, right, then we will be having only the transverse electromagnetic field in and around, that is, it will not be radiating, right? It will be there on the line, right? On the line we have, but it cannot be radiated. So to make it so that it can be radiating, what we do is that we are going to have the current has to be oscillating properly at the end. It has to, that is, it has to break, right? It has to break. So I just tell. So here we have now when we have a transmission line where it is an open loop, that is, the load impedance is infinite, then what happen here, the maximum reflection will takes place. So maximum reflection takes place, and then we will be having some standing waves taking place, so there will be no radiation. So there will be very minimum radiation, which will not be useful. So here we have to increase what we have to do here to make the two wires as antenna is that we have to just incline, that is, we have to incline with an angle that is called as flaring. So we have to flare, that is, or in other words, simple words, we can just tell that we have to bend to to approximately less than 90 degrees, right? So if it is 45, that means that flaring angle with respect to the line, if it is 45, it will be radiating the energy well, right? So flaring has to be done to make these two wires as to become as an antenna. Okay, about it then, right? So now this is the structure where we will be having the magnet. This is the structure of a two wire, and it has been flayed with 90 degrees. So we will be having the electrical field and the magnetic field produced out of it, and it will be radiating. Okay, and this now, that is, from the positive end of this particular transmission line, this will be like a dipole, right? So this will be like an dipole, that is, above that is the top one and the bottom one will be acting as dipole, and it will be having the maximization. Okay, and now this how the electrical field will be moving. So the field will be moving from bottom to the top, right? Okay, fair. And then this will be, right now, coming to the next one called as Hertzian dipole. The Hertzian dipole, if you can see, it is also called as top hat loaded, right? And it will be just, it represent like an capacitive plate element. So we know that Hertzian dipole, we have positive charge and the negative charge. Now based upon the very smaller elements, right, based upon the size of that particular Hertzian dipole, we can call, and we will be representing that as an capacitor plate antennas. Okay, and then if we can see the radiation pattern of the Hertzian dipole, so in terms of side view XZ plane, we can see that the lobes occurring towards the X direction, positive X direction, and the negative X direction, and similarly in the Y and Z plane we have towards only the Y direction, and from the top view only in the XY plane. So we have like a circular disc, right? So this is the radiation pattern of the Hertzian